Hi there, and welcome to this lesson. Now, in this lesson, we'll be learning differential calculus, okay? And under differential calculus, we'll be learning to find the derivative of a quotient. Yeah. And at this point, I'd remind you to set the video to play in 1080p HD. Very important that you do so you see everything clearly. And you can do so via the settings icon on the bottom right. And as the lesson progresses, if you have any issues at all, okay, anything comes up as unclear, please feel free to get in touch. Okay, we would be more than happy to help. Okay, let's jump right into the lesson. Okay, so differential calculus, the derivative of a quotient. Now, in the last lesson we talked about the derivative of a product. Okay, and basically then we had a function that was made up of two functions multiplying each other. But now we're going to have a quotient. Okay, so we have quotients, and basically what we have in this case, if you consider the function y equals x squared divided by 2x minus 5, you actually have two functions. Okay, and the function at one function is dividing the other, basically. So this function is made up of two functions with one function dividing the other. Now I'm going to call the function at the top u, okay, and I'm going to call the function at the bottom v. So we have that u equals x squared and v equals 2x minus 5. Now you'd agree with me that y is u divided by v, okay, and basically we have that dy dx is v du dx minus u dv dx divided by v squared. Now this formula is actually very similar. It is quite similar to the product formula, okay, but there are certain things you need to take note of. Now the first being the obvious one, basically we have divided by v squared in this case. So when we're done finding v du dx minus u dv dx, we divide all through by v squared, okay. And for the product formula we had a plus, but in this case we have a minus, okay, so there's a minus there rather than a plus, okay. And very importantly, we have v coming first this time. Okay, the order is very important here because you're finding a difference. So you have v du dx before u dv dx. For the product rule we had u dv dx plus v du dx, but now we have v du dx before u dv dx. So this just means we need to take note of, and we have our formula v du dx minus u dv dx divided by v squared. Now we're going to use this formula to solve for the derivative of the function y equals x squared divided by 2x minus 5. So we have that u is x squared and v is 2x minus 5. And then we have that dy dx. Now the first thing we're going to do is we're going to keep v constant. So 2x minus 5 multiplied by the derivative of x squared, which is 2x. So we have 2x minus 5 multiplied by 2x, okay. And then we have minus, and the next thing we're going to do is we're going to keep u constant, so x squared multiplied by derivative of 2x minus 5. The derivative of 2x minus 5 is 2, so we have that x squared multiplied by 2, and then we have all over v squared. And from this point on we simply simplify, so we have that if we expand the terms we have at the top there, we have that 4x squared minus 10x minus 2x squared, okay, and all over v squared, 2x minus 5 all squared, and we have a final answer 2x squared minus 10x over 2x minus 5 all squared. And that is how you find the derivative of a quotient. Now let's go ahead and solve a few examples. So I have an example here, example 1, and example 1 says if y equals 3x squared plus 7x divided by x plus 1, find the y dx. Now the first thing we want to do here is we want to get a formula, and a formula says the y dx equals v du dx minus u dv dx divided by v squared, okay. And then we get our parameters. We have that y equals 3x squared plus 7x divided by x plus 1. We know that u is the function at the top, so we have 3x squared plus 7x and then we have that v is x plus 1. Now let's go ahead and put all of that into our formula there. So we have that dy dx is, we take v, x plus 1, okay, and we multiply by that by the derivative of u. So if we differentiate u, we have 6x plus 7. So what we have is v du dx as x plus 1 multiplying 6x plus 7. Okay, now we're going to take, we have minus, and then we're going to take u, we'll keep u constant, and we differentiate v. So when we differentiate v is x plus 1, we have 1. Okay, and remember, all over v squared, x plus 1 squared. And from this point on, we just expand and simplify, and we have a final answer: 3x squared plus 6x plus 7 divided by x plus 1 squared. Simple, straightforward. Let's move on. Now I have another example here, and we have example 2. And example 2 says, if y equals x squared minus 3x plus 11 divided by root 3 minus x, find the y dx. Interesting. So now the first thing we want to do is we want to get our formula, a very simple formula. We have the v du dx minus u dx divided by v squared. Okay, and then we have the y, in this case is x squared minus 3x plus 11 divided by the root of 3 minus x. Okay, our u in this case is the function at the top, so we have x squared minus 3x plus 11, and our v is root 3 minus x. Okay, so let's put all of that into our formula. We have that dy dx is, we need to keep v constant, so we have root 3 minus x and differentiate u. So when we differentiate u, we have x squared minus 3x plus 11. If we differentiate that, we have 2x minus 3. Okay, and then minus, very important that you remember that it's a minus, not a plus. So we have minus, and now we're going to keep u constant, so x squared minus 3x plus 11, and we're going to differentiate v. So we have x squared minus 3x plus 11 multiply by, when you differentiate v, we have 3 minus x to the power of 1 over 2. Okay, you differentiate that using the function of the function, the derivative of a function of a function, you would have minus 1 divided by 2 root 3 minus x. And then you're going to have all of this all over root 3 minus x all squared. Interesting. Okay, so from this point on, we simply simplify. Okay, so what I'm going to do is I'm going to try and get because we have a fraction at the top there, I'm going to try to get a common denominator. Okay, so I'm basically just going to work that to get a common denominator, and I'll actually multiply root 3 minus x root 3 minus x multiplying 2x minus 3. I'm going to multiply that by 2 root 3 minus x just to get a common denominator at the top. Let's see what that is. So we have the y dx as 6x minus 2x multiplying 2x minus 3 plus x squared minus 3x plus 11 divided by 2 root 3 minus x. So I basically just try to get a common denominator at the top there, and then we have all divided by root 3 minus x all squared, which is 3 minus x. Okay, and then if we simplify that out, okay, what we have at the top there, and we basically bring our denominator there down to the bottom denominator, we basically put two of them together there, we have that. And when we simplify further, we have minus 3x squared plus 15x minus 7 divided by 2 3 minus x multiplying root 3 minus x. And that is how you find the derivative of the function x squared minus 3x plus 11 divided by root 3 minus x. Very simple, very straightforward. Let's move on. So example 3, and example 3 says, if y equals the cube root of x plus 5 divided by x squared, find the y dx. So The first thing we want to do here, so we have step 1, and the first thing we want to do, we want to get our formula. We know that dy dx equals v du dx minus u dv dx divided by v squared. Okay, and then step 2 says that y equals third root of x plus 5 divided by x squared, and then we have that u is the function at the top there, third root of x plus 5, okay, not x minus 5, and v is the bottom function, x squared. Okay, and now we're going to put these into our formula. So we have that dy dx is, we're going to keep v constant, i.e. x squared, and we're going to differentiate u. Now when we differentiate u, we actually have x plus 5 to the power of 1 over 3. And when we work that out, we should end up with 1 over 3 multiplying x plus 5 to the power of minus 2 over 3, which will give us 1 over 3 multiplying the cube root of x plus 5 all squared. Okay, just simple indices there. And then we have minus, okay, and we're going to keep u constant and differentiate v. So when we keep u constant, we have the third root of x plus 5, and we're going to differentiate v. We have 2x. The derivative of x squared is 2x, and remember, all over v squared, so we have x squared all squared. Okay, so from this point on, we just go ahead and simplify, and I'm going to work to get a single denominator at the top there, because we have a fraction there. So we have a single denominator at the top there, and what that gives us is we have x squared minus 6x, the third root of x plus 5 all squared, multiplied by the third root of x plus 5. Okay, and then we have divided by 3 multiplied by the third root of x plus 5 all squared, all over x squared all squared. And you can simplify that, and you'd end up with x squared minus 6x multiplied by the third root of x plus 5 all squared, multiplied by the third root of x plus 5, divided by 3 multiplying x squared multiplying the third root of x plus 5 all squared. And that is the derivative of y equals x plus 5 cube root of x plus 5 divided by x squared. Very simple, the quotient rule, very similar to the product rule. Basically, you have that dy dx is, you keep v constant, you differentiate u, and then you subtract, okay, very important that you remember that, and then you have keep u constant, differentiate v, and divided by v squared. And from that point on, you basically just do simple algebra and try to get like terms together, and you should arrive at a very simple answer. So yeah, bye for now.